moving forward with section 1.21 density question, which of the following diagrams show a substance in the solid, liquid, and gaseous or gaseous state? Which picture shows the highest density? Now, if we look previously, we've seen that density shows how packed together the molecules are in a material. That means more packed molecules means a higher density, less packed molecules means a lower density. Now, we know that in a solid is a substance that keeps its shape. Liquid is a substance that doesn't keep its shape, but still the particles are pretty tight together, and the gaseous state is the particles are just all over the place. That means they're not tight together, so they have the freedom to move. So the question is again, which diagram shows a solid, a liquid, or a gas? If you look at the compactness of particles, how close they are one to another, you realize that the highest density should be the one with the part where the particles are the closest, and the lowest density should be the one with where the particles are the farthest apart. Okay, probably you had the same answer that's on the screen. The solid is the tight particles, the liquid particles are a bit farther away one from another, and in a gas the particles are the farthest away. The highest density means the closest packed particles. That means the solid has the highest density, liquid has the intermediate density, and the gas has the lowest density. The next question would be, the next question on the bottom two, the above states have densities closer to one another while one of them has a much lower density. Which ones and why? So we can, it's kind of obvious here, closer one to another is either solid with liquid or the liquid with the gas. So we have two options. Either we have the solid and the liquid, their densities are closer one to another, it means their particles are pretty equal in tightness, in closeness, or the liquid with the gas. The solids and the liquids have densities that are close one to another because the molecules are packed in solids and only slightly moving in liquids, so they're pretty packed. While in a gas, the molecules are not tied one to another, they're not connected one to another, so they're free to move around. That makes gas having a much lower density. Consider air, for example. Consider air. In the middle you can consider the water, and on the left you can consider the solid. If we look at the table above, we see that there are three substances, one in a solid state, one in a liquid state, or one in a gas state. And if we look at the gold, which has very high density, 19,300 kilograms per every meter cube of gold. Now the water is only 1,000, so it's a bit of a difference from the gold to the water. But if we look at air compared to the water, air is only 1.33 and water is 1,000. So here the difference is almost 1,000 times. So as I wrote it on the bottom, gold denser than water 20 times, approximately 20 times, but more than 1,000 times compared to the air. Extension question: do you think water vapor is denser than air or lighter? Now think about the particles that make the composition of the water molecule. I think about the atoms or the particles that make the composition of air. The next part in our section, we need to talk a little bit about the law of conservation of mass, or about the conservation of mass. That means if we get a Snickers bar, for example, and we're going to leave it in a pack, and we're not going to open the pack for a long time, the pack should contain the same amount of Snickers bars as 1 month from now, or 2 months from now, or 5 months from now. If you're buying a Snickers bar that says 100 grams, and it has the validity date 2 years from now. When you're going to eat it 2 years from now, it should still have those 100 grams. That means because matter cannot just appear or disappear. That's because particles, atoms, they don't appear or disappear. They can only move around, mostly during chemical reactions, but they're not doing it by themselves. So the question is, if we melt 10 grams of ice, which is made of particles, of water molecules, will we get 10 grams of water? Now, water is also, liquid water is also made of water molecules. Might we also get 10 grams of water vapor? Water vapor is also made of water molecules. So we have 10 grams of water molecules, H2O, that look like solid or like a liquid or like a gas. If you answered that melting 10 grams of ice will give us 10 grams of liquid water or 10 grams of water vapor, you were right. You have the same you received the same amount, because here you have H2O particles, water particles, H2O, water particles, H2O, water particles in solid, in liquid, as in gas. Now, if we look at these three states of matter and the way that they change in between each other, we can see that we have the three states of matter, solid, liquid, and gas, and the transfer between one state to another, solid to liquid, is called melting, liquid to solid back is called freezing. Here the diagram shows water molecules. Liquid to a gas, going from liquid to gas, is called evaporation. Gas to liquid is called condensation. Going from a solid to a gas is called sublimation. From a gas to a solid is called deposition, or it's also called sublimation. Any changes of state of matter represent a physical change, not a chemical change. That means if I'm moving from ice to water, I'm putting ice in a cup which will melt eventually, I still have the same water molecule. So if I'm going to get the water in the cup, I'm going to put it back in the freezer, I'm going to get the ice particle again. The same thing, if a liquid evaporates, I get water vapor. Now, if that water vapor, for example, when taking a shower, condensates back on any type of glass or cold surface that you have in the bathroom, you still get water, liquid water. So because they are all water particles in all three states of matter, this means this is a physical change, because I can get back the material from the original. So 10 grams of ice equals 10 grams of water equals 10 grams of water vapor. They didn't transfer. If I melt something, it's not going to become something else. It's still the same substance. That is a physical change.